Introduce Kirsten Kurtz, who's the laboratory manager of the Cornell Soil Health Lab. She's also finishing up a master's in natural resources on soils and is also an expert soil painter, as you can see.
All right. Thank you guys so much. My name is Kirsten Kurtz. As Joseph said, let me just get my slides going here. All right. So I'm a soil scientist at Cornell University. Part of that role is managing the Cornell Soil Health Lab. I'm also a graduate student in natural resources, as Joseph mentioned. I'm interested in quantifying the health of remnant tallgrass prairies in the American Midwest, and I'm getting quite close to wrapping that up, I'm thankful to share. And I'm also a soil painter. I've received some amount of international recognition for my soil painting work. My undergrad is in fine art, and this painting on the screen here is an example of one of our soil paintings. This one won an international soil painting contest that was sponsored by the United Nations Food and Agriculture Organization. But today I'm really just going to talk about soil health and how we quantify it in our lab. So it's very important to approach soil health sampling with a question. In this case, we're interested in what are the differences between the no-till and the plow-till field that you see in this image here on the screen. And we really recommend that you take a representative sample. So what this means is that you want to sample from an area that really looks like the rest of the field. You wouldn't want to sample from somewhere that had, let's say, very tall corn if it's a cornfield, or very short corn. You're really looking for that average. And when you're thinking about this, we recommend approaching the field with a W or an M shape, as you can see here on the screen. And what you would do is each one of those points, you would take a subsample and a penetrometer reading, which I'm going to talk about more later. And then at the end of completing your W pattern across the field, you would combine those samples, mixing them super well in the bucket, and then you would pull out a 4 to 5 cup subsample, which gets sent to our lab. We do have an extensive video on exactly how to take a sample for our lab. It is a little bit different from other types of soil sampling. The video is about 9 minutes, and you can find it on our website if that's something you're interested in learning more about. All right, so I think that you guys are probably all familiar with sort of the NRCS definition of soil health. To me, the most important thing about this definition is it's about the capacity of the soil to function, right? That's extremely key. And also the vital living ecosystem, which is really that soil health that we're talking about, the living soil system. And when people talk about soil health, what they're really talking about is the biological, the physical, and the chemical aspects of soil, and looking at them in a holistic way. So when we're talking about the biological soil properties, we're really talking about the biota, the life of the soil. And this is really what Janice Teese was getting at with her talk before mine. We're talking about carbon, which there's a lot of talk about carbon these days. I'm going to be talking about carbon a lot. And we're talking about organic matter. When we're talking about the physical aspects of soil that we're really trying to drive at here, we're mostly talking about the structure of the soil and the texture of the soil. And then, of course, we also are interested in those chemical aspects, including pH and those minor and major nutrients. And the way that we approach this in our lab is that we found these indicators that are highly changeable by management for the biological, physical, and chemical aspects. And you can see we have quite a few biological tests listed here. Some of those could arguably be included in the physical or chemical aspects also. And the way that we look at this is that we rate them using our scoring curves, which you can see on the left-hand side of the screen. And we're rating your results against all of the rest of the results we've gotten in our lab. So we've gotten over 10,000 samples. And we're kind of saying, this is where you fall in against everything else. And you can see here, I included the scoring curves for the total carbon and the total nitrogen. This is our newest test that we just started offering this year. And you can get an idea of kind of how this works. And it's worth noting that there's differences in the texture and how we rate according to texture. So you can see coarse, medium, fine down there at the bottom. And if you have a coarse textured soil, you're going to have a different overall soil health score than a fine textured soil in most cases. All right, so I'm going to start by talking about these biological indicators, quite literally the life of the soil. And I had to include a couple pictures of some of those soil microbial community members, including the one all the way at the bottom to the left, which is the tardigrade. This is my favorite soil creature. It can actually survive in space. It's a very amazing part of the soil microbial community. All right, so of course we have to start by talking about soil organic matter. This is extremely important. And indeed, the amount of organic matter that you have in your soil is going to have a lot to do with how healthy your soil system is. And this is quite simply a measure of carbon-containing material that is or is derived from living organisms, including plants and other soil-dwelling organisms. We measure soil organic matter in our lab in the same way that almost every lab does, which is called loss on ignition. So basically, we burn off everything that can burn off. We weigh it before we burn it. We weigh it again. We apply this equation, and then from that, we're able to report your percentage of a soil organic matter. And again, this is a very standard method. All right, so we also look at soil protein in our lab. This is a test that we developed in-house. We've actually developed quite a few of our tests in-house. And soil protein is typically majorly derived from plant residues in soil. And the way that I like to think about or kind of simply explain what soil protein is really it's that bioavailable nitrogen within your soil organic matter. And this is part of that active part of your organic matter. You can see here on this chart kind of an idea of what portion of that is active, which includes the respiration and the active carbon, which we'll talk about more later today. So the way that we do this in the lab is somewhat complicated. This is actually our most complicated soil test, and this is starting to be picked up by other soil labs around the country and around the world. But in brief, we extract the proteins from the soil, and then those aggregates are dispersed using a sodium citrate buffer. We then autoclave that solution and we pull out a 2 ml slurry solution, which is then centrifuged. We then analyze this extract using a standard colorimetric protein quantification assay. We use the BCA protein assay, and then it's read for color with the spectrophotometric plate reader. And you can kind of see that's that last step that we see here on the screen, the way that those colors change. We also measure soil respiration in our lab. This is a test that I would assume that many of you are quite familiar with. And this is really as simple as looking at the amount of CO2 that's being released by this microbial community over the course of 4 days. And this is really kind of a proxy for abundance and more so a proxy for metabolic activity of the microbes, right? So the way that we do this in the lab is a little bit different from the way that some other folks measure respiration. So some of you might know you can measure respiration in the field and you can measure respiration in the lab. Some folks do a 1-day incubation. we do a 4-day incubation. And this is because we know that when you first wake up those soil microbes, they give this burst of energy in that first day. And we want to see, so it's possible that your soil could have a burst of energy, but then completely drop off, right? So we think that if we look at it over the course of 4 days, that gives us more of an idea of what that functioning is. So for this test, we take 20 grams of air-dried soil. Indeed, we use air-dried soil for all of our tests because we're interested in getting at that life of the soil again. And we add it to these jars in this little aluminum weigh boat that has these holes poked in the bottom. And then we pipette in some water, which kind of comes up through the bottom of that weigh boat and wakes those organisms up. We then place a little beaker of KOH into this trap assembly within this jar. We seal it, and then at the end of those 4 days, we measure the conductivity of that KOH, which from that we're able to determine the total captured CO2. We also measure active carbon in our lab. This is a very well-established soil health test. This was developed by Ray Weil, and it's a very strong test as far as getting at the overall soil health. And the way that I like to think about what active carbon really is it's along the same lines as what I was talking about with protein. So in this case, we're talking about the part of the soil organic matter that can be easily metabolized and used by the microbes and also re-released as nutrients. And that's that active carbon. The way that we measure this in our lab is, again, we take a known weight of air-dried soil and we put it in with 20 mils of potassium permanganate. We shake this for 2 minutes, we let it settle for 8 minutes, we then stop the reaction. And the way that this test works is that the more carbon, the more active carbon you have in your soil, it actually bleaches out. So if you recall that slide that I had just shown where we have kind of a range of colors, if you see a lighter color, that actually means you have higher levels of active carbon. And this, similarly to the protein, is also measured using a colorimeter. We actually use a pocket colorimeter in our lab to do this. And one of the things that I really love about the active carbon test is that you could actually do this in the field and you could share with a farmer or a client in real time what your active carbon results are. We also, as I mentioned, have just started looking at total carbon, total nitrogen. This is obviously extremely important. When we're talking about total carbon here, we're talking about the organic and the inorganic forms of carbon. So, earlier I'm talking about active carbon. That's kind of just this part of it. This is everything. We're really trying to get at that total number. And we're also looking at that total nitrogen number, right? So this is, again, extremely important, not only for the carbon nitrogen ratio, but just in general to understand the functioning and potential of your soil. So for this test, we got this new piece of equipment from Scalar. It's called a Primax NSC 100 carbon and nitrogen analyzer. This is a very cutting edge piece of equipment. We're very lucky to have it. My understanding is there's one, possibly 2 other labs in the United States that have one of these. And it's a really interesting machine because the way it works is that you basically put your soil into these little jars, and then they're on a carousel. And what happens is that the machine will pull in the samples individually and then down and subject them to different temperatures. So the total carbon is obtained by completely oxidizing that carbon to CO2. This is done using a very high temperature combustion, 1100 C. And then that CO2 is measured using a non-dispersive infrared detection. The total nitrogen is using the Dumas methodology, which I think some of you are probably familiar with, but it's the same kind of concept in that we're actually combusting that nitrogen, using oxygen. That gas is then removed or is moved to a reduction furnace where that nitrogen is then reduced to N2 and measured using thermal conductivity detection. So we're very excited about this machine, and we're extremely excited about the research that is going to come out of this internal research within our lab. All right, so then we also look at a suite of physical indicators as listed here on the screen. The first I'll start with is aggregate stability, and we learned quite a bit about aggregates today. But again, aggregates are really those crumbs of soil that you can see here in the soil sample all the way on the right-hand side of your screen. These two soil samples were actually taken at my research plots in Nebraska. And you can see here, this middle sample has been heavily cultivated and has been in continuous corn for a very, very long time. And the one next to it is a remnant prairie. And that's kind of what that soil aggregate potential can really look like. And we're interested in how stable those actual aggregates are, because I think, as you can see from this screen, management can really destroy those aggregates. It's very sensitive to management, especially tillage. And this is what those samples would look like in our lab. So if you think about that middle sample that was kind of all smeary, that would be one of these 3 sieves that don't have very much soil on it. And then that other sieve actually came from one of those remnant prairies. So the way that we do this is that we remove any unstable or failed aggregates using a shaker. And then we put a known weight of soil onto a soil sieve with a filter underneath. We then simulate a rainstorm on these samples, at which point any aggregates that can fail do and fall into the filter. And then what remains is stone and stable aggregates. We then force the stable aggregates through the sieve, and we dry and weigh the stones. We dry and weigh what we lost to the filters, and from that we're able to report your percentage of aggregate stability. And this test was also designed in-house. We also look at soil texture. Of course, soil texture is really an inherent soil quality. And by that, I mean it's very hard to change. But it's extremely important for us to understand to interpret your other results, as well as for you to understand for management decisions. So we basically just look at the percentage of sand, silt, and clay. And we use this textural triangle that you can see here on the screen. And then from that, we'll tell you your actual percentage, as well as if you're a silty clay loam, etc. So we did develop this method in-house also. We call this the rapid soil texture test. And this is actually a very strong test, and it's relatively inexpensive for providing those percentages. So what we do is we take, again, a known weight of soil, we shake it in a sodium hexametaphosphate solution, which is basically a soap solution that separates the sand, silt, and clay particles from each other. And then we dump what's in those little tubes through these very fine sieves that catch all of the sand, but the silt and the clay go through into a beaker. The beaker is then left to settle for 2 hours. Over that time, we know, according to Stokes' law, some of you guys might remember from physics back in the day, we know that the particle size of the silt is going to settle, while the clay is so much smaller, it will remain up into that water solution. So at the end of the 2 hours, we simply decant off the water in the clay. We rinse the silt into a tared weigh can. We have our sand in a tared weigh can. They get dried, and from that, we're able to report your percentage or your specific soil texture. We also measure available water capacity in our lab. So this test has been around for a really long time. And we look at two specific points, which is field capacity and permanent wilting point. So field capacity is basically when your soil is completely saturated with water, but it's not free flowing due to gravity underground. It's as much water as that soil can hold. And then we look at the far other end, which is called permanent wilting point. And permanent wilting point is when your soil is incredibly dry to the point where it's actually pulling moisture out of the plants themselves to the point that they can't come back from it, quite literally permanent wilting point. And I wanted to include this little table here on the screen that shows you how much of a difference you can have in that available water capacity depending on your textural class. Again, texture is incredibly important, and it's important to understand the potential of your soil, right? You're not going to necessarily be able to bring, you definitely can't bring a coarse sand to the available water capacity of a nice sandy loam. It's just not how it works. So it's important to understand those goals. And the way that we measure this in our lab, again, very standard, is that we use these ceramic plates that have a known porosity. So we have two different pressure chambers. You can see here on the screen, the upper picture there is what these pressure chambers look like. And the field capacity pressure chamber extracts water to 10 kilopascals. And then the permanent wilting point is 1500 kilopascals. After these samples have equilibrated, which basically means that all of the water has been pulled out to those levels, we then remove the samples, we weigh them, we dry them in an oven at 105°C overnight, and we weigh them again. And from there, we can get those 2 points that really show you what your range of capacity is. All right, so we also are very interested and look at surface and subsurface hardness. This is really about compaction. We heard Dave speak up quite a bit about compaction. Compaction is a big deal in managing for soil health for many reasons, including for the infiltration of water and for the uptake of nutrients in your field. So this is the only one of our tests that are measured by the farmer, by the consultant themselves using a penetrometer, which you can see here in this picture on your screen. And a penetrometer basically measures resistance in the soil in pounds per square inch, PSI. So we're interested in looking at the surface hardness, which we consider 0 to 6 inches, and in the subsurface, which is 6 to 18 inches. And what you want to do is you push this thing down and you want to record the highest PSI that you see within that range. So we know that root growth is limited around 300 PSI. So we're really looking for something under that. And when we start to see numbers pushing or exceeding 300 PSI, we know that we need to get in there with some kind of serious management to address that compaction. So, of course, we also offer those chemical indicators, and the best way to think about this is kind of more as a typical soil test, which would include these things plus organic matter. So, of course, we look at pH, it's 2 to 1 water, and we look at the major and minor nutrients. We do use modified Morgan as an extractant in our lab. So that's worth keeping in mind if you're sending samples from other parts of the country. It might not be the ideal extractant. We are able to offer Malic 3 also. All right, and then what that brings us to is our soil health report. So this is the first page of a 10-page report. And I just want to give you guys kind of an idea of how to look at this. First, I think that everyone can notice it's very visual. That's very important to us. We're all extremely interested in communication and easily sharing these somewhat complicated concepts. So I think right off the bat, you can see that the sample on the left is not doing nearly as well as the sample on the right. So these samples were taken 10 feet away from each other. The sample on the left has been intensely cultivated here on campus, and it's been tilled often more than once a year. So it's really been used hard, as one might say. Whereas the soil health report on the right is the grass directly outside of this. And this kind of gets at one of those first slides I showed you guys when I'm talking about comparison sampling or approaching sample with a question. And the other thing that I think that this really provides us is an aspirational goal, right? So let's say you're trying to come in and manage this soil on the left. It's really nice to have an idea of how good you could possibly get it, right? So it's more of a realistic idea and goal for the long-term improvement of your soil health. You might also know that we have some highlighted red words under the constraints. This is where we talk about, for instance, that top one, surface hardness, and then we say exactly what those constraints are: rooting, water transmission, as I kind of mentioned before. And then if you go through the pages of the report, we'll give you much more information about that. And we'll say, okay, your surface hardness was 260, that's a poor rating, and a lot more information on options for how you can address that. And indeed, the last page of our soil health report is the short and long-term management suggestions. So unlike some other soil labs, we don't make recommendations. We make management suggestions. And you'll notice I highlighted the protein in this case. And you'll notice that we make short-term suggestions and long-term suggestions. And part of the reason that we have multiple options here is because no farm is really like the next, right? It's important to not just say, you have to do this exact thing, add this cover crop. Maybe the folks don't like cover crops for whatever reason. It's important to have multiple options. So just briefly to work kind of through these concepts, we know our soil protein is directly tied to bioavailable nitrogen. So of course we see in short term suggestions to add nitrogen rich organic matter. This would be a nice compost, maybe a composted manure. We've got, some suggestions with cover crops. And then in the long term, we're going to be thinking about reducing tillage. We're going to be thinking about more rotation. We're going to be thinking about monitoring the pH. And these, I think, are some of the more valuable things that we're really offering, is simplifying these concepts. And there's, you could probably do an entire presentation on short and long-term suggestions for managing soil protein, but we're really trying to simplify these concepts and help everyone really wrap their head around it. All right, with that, I am pleased that I do have a couple minutes for questions. And I wanted to also add that everyone should feel free to reach out to me directly via email or what have you, if you have any specific questions about anything that I talked about today that we may not have time for. And with that, thank you.